Hello, everyone. Thank you so much for joining us for this Hurricane Hazard Series Q&A. So as you may know, May is South Carolina Hurricane Preparedness Month. And I have representatives from all 4 Weather Service offices here with me today to answer questions that were submitted by our respective social media followers. And starting with me, my name's Steve LaVoie. I'm a meteorologist with the National Weather Service in Columbia, South Carolina. And I have been here for 5 years next week. So very exciting. Next up, I'll turn it around to Clay.
Hey, so I'm Clay Cheney, meteorologist out of the National Weather Service office in Greenville-Spartanburg, South Carolina, covering western North Carolina, upstate South Carolina, and northeast Georgia. And I've been here for a little over 6 years.
All right. We'll go to Anna next down in Charleston.
Hi, I'm Anna. I'm one of the meteorologists here at the National Weather Service in Charleston, and I've been here a little over 2 years.
And up at Wilmington, Vicki and Ian.
Hello. Yes, Ian Boatman here, National Weather Service in Wilmington. I'm coming up on 7.5 years of being at this office. I got here in December of 2019, and we cover parts of northeast South Carolina and southeast North Carolina.
Hi, and I'm Victoria Leva, meteorologist at the Wilmington office, and I'm coming up on 8 years and 2 weeks.
Awesome. So as you can see, the state of South Carolina is covered by 4 different weather service offices, and I am in the Midlands here. So we are near the capital of Columbia. So we cover the central part of the state and then a couple counties in Georgia, the Augusta area. And so thank you guys for being here. This is the second time we've done this. We did it way back in 2022. So Clay and Ian are veterans, and our newcomers are Victoria and Anna. So welcome, and let's get this going. So taking a look at things, this is the official list for the year 2026. This is the naming list. It rotates through every 6 years. So this is the same list, more or less, than the one that we used back in the infamous 2020 season. During the year 2020, we had 30 named storms across the Atlantic Basin. We had so many that we actually went into the Greek alphabet. And after that season, the name Laura was retired. So you'll no longer see the name Laura on a hurricane season list in the Atlantic. That was replaced by Leah. And actually, if we ever go more than 21 storm names, we used to use the Greek alphabet. We used it in 2005 and then again in 2020. But after those storms were particularly destructive, we decided we're no longer going to use Greek names, and we have a backup list, effectively. But for this year, we start off with Arthur, Bertha, Cristobal, Dolly, Edward, Faye, Gonzalo, Hannah, Isaias, Josephine, Kyle, Leah, as I mentioned, Marco, Nana, Omar, Paulette, Renee, Sally, Teddy, Vicky, and Wilfred. And so every name on here, except for Leah, as I mentioned, has been used at least once, and that was mostly attributed to 2020. And you can see like Gonzola and Omar were used a couple times, and you'll see a lot of those male names haven't been used too much because we started this rotating list in 1979. So that was the first year we started using male and female names, but we've actually named hurricanes all the way back into the 50s. And so the name Dolly, which is on this list, was used back in 1953 and Bertha in 1957. And Bertha actually, along with any of the names you see in red, were on that original list. And that was first used in the Atlantic in 1984. And with that, we're going to get to your questions. And Anna will take it away from here.
Okay, so the first question is, what is the overview impact of El Nino versus La Nina oscillation on hurricane development in the Gulf and in the Caribbean? Well, it actually plays a big role throughout hurricane season. We're just entering El Nino, and this will continue into the fall, which means we usually have fewer hurricanes just because there's a lot more vertical wind shear, which tends to rip hurricanes apart easily, and they're not able to develop or form, and typically they tend to be a lot weaker. And then vice versa with La Nina, there is a lot less wind shear, so the hurricanes are able to develop quicker, and usually they tend to be stronger. So this season going into El Nino, just as a reminder, just because there is a lot of wind shear, across the Atlantic Basin does not mean that you need to put your guard down, because it really does only take one storm.
All right. And next up is going to be Clay, who's going to talk about hurricanes in South Carolina.
All right, so the question for this slide was, how common are hurricanes in South Carolina? Overall, between 1851 and 2025, you can see we've had 24 landfalls, so we get one every 7 years, and typically between June through October. But you can see once we start to hit the peak season between August and September and October, that's usually when we're kind of on guard for the best probability for us to get a landfalling hurricane along the coast of South Carolina. And just kind of looking at the list down here on your bottom left, you can see all of the actual hurricanes that have made landfall. And there's actually only been 3 major hurricane landfalls. You can see with Hugo, of course, in 1989, Gracie in 1959 is a Category 4, and Hazel in 1954 is a Category 4. So it's been a while since we've had a major hurricane make landfall along the South Carolina coast. I also want to reiterate that we're not only looking at landfalling hurricanes from the Atlantic, we also need to be concerned about the ones that make landfall in the Gulf, in particular on the eastern side of the Gulf, as we saw back in September 2024 with Hurricane Helene and the impacts that it made, especially across the upstate and the Midlands.
And now we're going to talk about hurricane prediction and send it over to the team in Wilmington.
Yep, so this question from Gretchen is, which is overall harder to predict, Gulf potential hurricanes or Atlantic? So I will start off by saying officially forecasts are verified by Basin, so both Gulf and Atlantic storms are all part of the Atlantic Basin. So our track record is the same for both Gulf and Atlantic. One caveat to that I do like to mention is rapid intensification, where storms ramp up really quickly over a short period of time. That's more likely in the Gulf and as well as the Caribbean. And historically, forecasting rapid intensification has been difficult. We have been getting better, especially over the last 5-10 years. But it can still be difficult to forecast rapid intensification. So that's one part of Gulf storms that is trickier compared to the Atlantic. And another thing I want to mention when it comes to the track for both of them is when you're looking at forecasting the track for an Atlantic storm, you're sometimes trying to figure out whether or not a storm is going to make landfall or stay out to sea. Whereas in the Gulf, you're pretty much just determining, is it going to make landfall in one location or another? Since it is, given the land in the Gulf, it's pretty much just going to be where's the landfall. So it's more sensitive to track in the Gulf versus the Atlantic.
Yes, and I know that RI is it is a challenge. I think you'll see over time that our track forecast at the Hurricane Center, they have been improving over time, but rapid intensification, or RI, is still really tricky. I remember way back in 2004, there was Hurricane Charlie was one that slammed right into the Tampa area. So that's just one example of a storm that just kind of exploded as it approached land. And yeah, that's always, I would definitely agree, it's definitely trickier in the Gulf because, again, not only, as you mentioned, you have basically land all around you, so unless that storm kind of fades away, it's going to hit something somewhere. And we have seen many cases like that. I believe that the Category 5s that have made landfall in the United States, they all were very, like, weak tropical storms just a day or two before landfall. So they all rapidly intensified as they made it onto land. So definitely something tricky to keep in mind. All right, and I'm up next with a question from Roger Byers. Why is the upper right or right front quadrant of a hurricane the most severe? And he does use Hurricane Helene, so he said that it was a prime example, and there was significant wind damage in the Augusta area as that quadrant passed over. And so first off, for those not familiar, if you take a look, this is actually what Helene, this is an image of Helene while it was in the Gulf. And so when we're talking right front, it's this part of the hurricane. And so that is the area where it just, all the ingredients come together to produce the worst hurricane effects. Mind you, even if you're over here, which I guess we'll just call the left back quadrant, there are still going to be major impacts. It's just you're more likely to run into the higher level, the higher magnitude over here. So what happens here is, imagine that this hurricane is moving due north. Well, whatever the wind speed is associated with the hurricane, you're also adding the forward motion. So the winds are even stronger as you're on that side of the storm. So that also applies down here. So the right side of the storm, we're moving with the forward motion, as opposed to the left side of the storm where it's going against it. So the winds are slightly lower. But keep in mind, if a hurricane's moving, like 150 mile per hour hurricane is moving north at 10, that means one side's getting 160 and one's getting 140. Those still are very strong winds. So just because you're on the quote-unquote weaker side does not mean you're safe from a hurricane. Not only that, but the greatest storm surge is going to be in the front of the hurricane because all the winds are pushing forward onto the land, again, particularly in the right front where you've got that forward motion, you've got the winds around the hurricane, it's just coming in and moving into land. And also, this little graphic here, I stole from the Storm Prediction Center, and so this shows you where hurricanes associated with tropical cyclones have spawned. So imagine right here is the center, and you see the vast majority are in that right front quadrant, where you need a little bit of wind shear for a hurricane, for a tornado to form. And so within the rain bands, there's an extra bit of spin associated with the right front quadrant. And you can see that's exclusive to the right side of the storm, basically. So no matter where you are, you have something going on, but the winds are the strongest in the right front specifically because you have that forward motion going. And with Helene was moving incredibly fast. It took, I think, 6 to 8 hours to go from landfall in Florida to up to the Augusta area. It was rapidly moving north, which again allowed those strong winds to penetrate so far inland compared to usual. And in this case, it was something going beyond the storm itself, where kind of the core of Helene was actually collapsing, and those strong winds went right through the western part of the Columbia forecast area and then right into the Greenville-Spartanburg area, where you had this massive swath of those incredible winds that just swept up there. So here in Columbia at the airport that night, we got to about 70 miles per hour in gusts. So the core just missed Columbia, but off to our south and west and into the Augusta area. As you can see by these pictures, the impacts were simply devastating. All right, next up, we're going to talk about some tropical cyclone tornadoes.
All right, so the question is, has there been any observed tornado warnings from tropical systems in the National Weather Service Charleston CWA before? Yes. This is typically when we do see our most tornado warnings, is when we have a landfalling tropical cyclone. And just like Steve just talked about Hurricane Helene, this is a prime example. We're in the right front quadrant here as it was passing nearby, and we end up issuing 39 tornado warnings that night, and we're able to confirm 6 EF0s and 2 EF1s. Now, typically these tornadoes form within these rain bands, and they'll spin up really quickly, and they tend to be weaker and short-lived, but they still pose a very significant risk.
Yes, and I think Debbie earlier that year was also a prolific tornado producer, right?
Yes, not as many as Helene, but yeah, I think we had at least 10 tornado warnings out that night as well.
So, and that's, I brought up Debbie because Debbie, as it moved ashore, that came in from the Atlantic, initially made landfall in the Gulf again, and then went offshore and then came into South Carolina. And I mention it because Debbie was just a tropical storm, specifically a subtropical storm at landfall. So you don't just have to have a hurricane to worry about tropical cyclone tornadoes. In fact, oftentimes we'll get the remnants that come through and will go through. Hurricane Francis in 2004 was a particularly prolific tornado producer for the state of South Carolina. And there are examples after examples of, big tornadoes that don't get spawned by a hurricane specifically. And with Helene, too, what was interesting is I was on radar that night. So as these rotations were coming in from Charleston, well, we're next in line. So we actually had that night 10 confirmed tornadoes after that. So they just kind of kept spinning as they came closer and closer. But as you started moving towards Augusta and Columbia, we didn't see the as favorable conditions as you got closer to where the core was. It was mostly in that right front quadrant. So a lot of folks in Augusta saw what looked like tornado damage, but that was actually non-tornadic. Our radar is actually able to show you the signatures that are capable of producing that rotation. So we had a lot of folks in Augusta who were wondering, well, you know, I could have sworn it was a tornado. It sounded like a freight train. And it was just the incredible force of Helene's core and those winds in that case. All of the tornadoes we confirmed were off to the southeast of Augusta and Columbia. So definitely a big storm that had that tornado component, but not just tornadoes. There was a strong winds out west. Okay, next up we've got eyewall replacement cycles.
All right, so this question came from Facebook, and it asks really 3 questions in one. What causes eyewall replacement? Is it related to energy? Is there a maximum time specific eyewall can be maintained? Is it related to heat and energy inputs? I would say yes to 2 and no to 1. So I'll break that down here. And basically, really when you go through an eyewall replacement cycle, you mostly see them in major hurricanes. And essentially what happens is that, you know, the initial eyewall at the core of the actual hurricane develops, and you have a really nice structure to it. Well, eventually what happens is that this core starts to weaken, and eventually you start to get, you know, a lot of drier inflow and some frictional force to kind of go along with that. At the same time, there's a secondary eyewall that's also forming at the same time. And so what happens is that the initial eyewall starts to contract and actually start to weaken a good bit. And as that's happening, the secondary eyewall starts to form around it. Now, when that happens, I have a lot of people ask me, you know, when it goes through an eyewall replacement cycle, does that mean you're going to get this ginormous hurricane that's going to be a lot stronger? Typically, no, as far as, you know, the core of it getting stronger than what it initially was, but the wind field actually broadens. And so when in that case, you get a lot of more widespread, like tropical storm force wind gusts and even hurricane force wind gusts once you get closer to, once that secondary eyewall starts to, you know, become organized and officially becomes the new eyewall with that hurricane. But wanted to point out that heat and energy matters a lot when it comes to eyewall replacement cycles. It really depends on, you know, the ocean temperatures, the actual ocean heat content that's provided, and being able to actually sustain, you know, the actual convection to go along with the different eyewalls. And so heat and energy matters a lot. The part of the question where I said that I answered no to is that there's actually not a maximum time that an eyewall can be maintained. It's very different. I know for one example, with just last year with Hurricane Melissa, right before it made landfall in Jamaica, you know, everybody was kind of anticipating it to go through an eyewall replacement cycle, and it actually never did, and it was able to maintain itself over a long period of time. So just because the eyewall is still there, even though, you know, in scientific reasons, with a major hurricane, you're expecting an eyewall replacement cycle within a couple of days, usually at a maximum time, it doesn't mean that it's actually going to form. And so this is even more so see this with, you know, hurricanes that have a smaller eyewall, kind of has more of a pinhole, you know, eye to it instead of ones that are super broad. And able to maintain the eyewall a lot better. So usually it just varies with each storm, and that kind of goes off to the point as well that every storm is different. And so whether that be, you know, just how it's actually configured and the way it looks, especially, you know, based on satellite or radar data, and also the impacts. So impacts are always going to be different as well from, you know, just about every hurricane that develops.
All right, this one's a fun one. Let's talk about what the Fujiwhara effect is, which this comment is actually referring to.
Yeah, so Chris asked, what would happen if 2 hurricanes were to converge on each other? Would the storm become worse in intensity, or could they both become less intense? And something that he's always wondered. So yeah, what Chris is referring to is the Fujiwhara effect. So this happens when 2 hurricanes get relatively close to each other. And when I say relatively close, I'm talking about in the ocean, talking like 500 to 1,000 miles apart. And what happens when these two hurricanes get close enough to each other where they start to, I guess, feel each other, for lack of a better word, is they start to spin around each other, around like a common center. And a few things could happen. One, which is probably one of the most common instances, is if they have similar strength, is they kind of move around each other for a while, but they don't merge. So they kind of influence the track. And we saw this just last year with Hurricanes Imelda and Umberto. For those that remember, the original forecast for Imelda was for it to make landfall in South Carolina about 3 or 4 days out. And then Umberto strengthened right to its northeast, and it pulled Imelda to the east. It pulled Imelda straight away from the United States because these two storms started impacting each other's trajectory. So that's the most common Fujiwhara effect. The other one, which is just slightly less common, but still we still see, is if one storm is stronger than the other, you can see the smaller one kind of orbit that stronger storm before it weakens and either dissipates or becomes absorbed. And again, this happens sometimes during like the peak of the hurricane season where you have multiple storms in the same basin. And on rare occasions, you might see an additive effect where the two hurricanes kind of come together and might be slightly stronger than what the individual storms were. But I will say this is rare. But I know this is what a lot of people think of when they talk about merging hurricanes as it becoming a monster storm. It's not. That's not usually what happens. What happens is the two of them spin around each other, and either one gets absorbed or they both just spin off to do their thing.
So Kevin Lundy asked, emergence of Google AI-based model and its albeit short track record in modeling hurricanes versus traditional models. So we did come up, there are some new AI-based hurricane models. The one that he's referencing is the Google DeepMind. And so the tracks, these images that you see here come from the official National Hurricane Center report on Imelda. And so the tracks that Google DeepMind used are down here in the lower right. I put the red box around them. And that's compared to the official forecast track from the Hurricane Center in the upper left, the Global Forecast System, GFS, in the upper right, and in the lower left is what we call the European model. And on the left here are the initial model suites for when we started tracking what would become Imelda. And you can see that they were kind of divided on what would happen. So there were a lot of models that initially said it would go through the Bahamas and either make landfall in South Carolina or stall just off the coast and then head out to sea. They were having difficulty actually resolving the potential Fujiwhara with Umberto. And the dark black line that you can see is actually what Imelda did. And you can see that Imelda did indeed it stalled, but nowhere near South Carolina, well off to the southeast, and then took that very hard turn out to sea and actually ended up impacting Bermuda as a hurricane. And if you compare the official track, initially a Hurricane Center went more towards the drifting up towards South Carolina, never predicted landfall, but you can see most of the guidance did have that kind of split between either heading out to sea or stalling near South Carolina. But the DeepMind never had anything near South Carolina. It always showed that turn, and over time it got better and better at showing it's going to make that right turn well before it gets to the state. And so we did have that possibility there. Of course, here in South Carolina, we were getting prepared for the possibility of Imelda actually making landfall or having some more significant impacts than it did, but besides just high seas and surf. And I mean, now the folks at the coastal offices could chime in on any Imelda-based impacts in particular, because I do recall kind of a additive effect, if there was, between Umberto and Imelda for a couple of days off the coast, or maybe I'm, if I might be mistaken there. But overall, I do want to surmise that this is just one new tool that meteorologists have. So while it did well with Imelda, each storm will have its own biases. Each model will have its own biases. So we want to use them, collectively. So just because Google did well with one type of storm, we're not going to just jump over to Google and use the DeepMind for every hurricane. We'll certainly keep it in mind, and in this particular case, it did quite well. And now we're moving into the next couple of questions had to do with a lot with preparation and evacuation. So let's hop down to Charleston again.
All right. Okay, so the question is, have evacuation plans and routes been updated / changed in relation to the large population growth we've had in the last few years? Yes. So since, the population is growing faster than the city can keep up with, or most of South Carolina can keep up with, they actually changed the evacuation zones back in May 2024 to better reflect the population distribution patterns. And this takes into account surge risk, flooding, and evacuation routes to ensure more accurate and effective evacuation orders. As you can see, the evacuation zones are classified A through F, A being the most vulnerable and F being lesser vulnerable, but still vulnerable. I belong in zone B, so I guess second most vulnerable, but you can actually find your zone at that link right there, and look up your address of where you are, and it will tell you exactly which zone you are in immediately. And then it also has good guidance on what to do when, evacuations do occur. Where do you go? How do you prepare? So it's a really great website. But this is important to know before hurricane season. You don't want to do this last minute and start, being like, oh my God, I have no idea what zone I'm actually in. So look at this, know your zone, and be prepared for this upcoming hurricane season.
All right, and I'm going to start with Anna, since this is your question, but then I want to go up to Team Wilmington. Which communities do you guys think are most exposed to the storm surge threat? So starting in the Charleston area.
Definitely the coastline and the low-lying areas. I mean, it depends on the topography. We have a lot of marsh land down here, so definitely near the coastline. And then if you're near, a river or a more marshy, elevated like sea level rise area, they're definitely more vulnerable to storm surge for sure.
And is the city of Charleston, is that B, zone B?
Yeah, that's zone B, yes.
Okay. And what about Team Wilmington? For the South Carolina counties in particular, where do you think is kind of the area with the most exposure to storm surge?
Even with storm surge notwithstanding, just a regular old thunderstorm, Myrtle Beach can flood really easily. That whole area, Myrtle, North Myrtle, Atlantic Beach, that whole area, they flood so easily. So then you throw a tropical storm or a hurricane in the mix, you have some serious storm surge concerns, and that's why you have those areas on that map highlighted in parts of red, orange, and yellow, those evacuation zones. Horry County itself is a little deceiving because it's a little hillier than you think. The coast itself is sea level, obviously very low, but when you leave Myrtle Beach and those areas, you go up a little bit. And that's why those coastal zones, those evacuation zones, are pretty skinny. But in those areas, just in and of itself, that hyperlocal area, those are very susceptible to flooding in general. And then you throw storm surge in the mix, you have a really nasty situation that unfolds. And we see this a lot in these coastal storms and these hurricanes that if they don't make landfall, if they just graze the area, we have serious concerns to contend with in those areas.
And then, if you go south to Georgetown County, right around the inlet to Lake City, Georgetown, and Pawleys Island, that area is very low-lying, and we have had some storm surge cases in the past. So that hence why you see that big Zone A in southern Georgetown County.
Great. Thanks so much for sharing that with everyone, because I know we have, every year, new people are coming down to South Carolina, and a lot of them are moving down to the coast or like to vacation there, so it's always good to know which areas are most likely to have issues with storm surge and other hurricane hazards. Thanks. All right, now moving up to Clay. Got an interesting question there. Go ahead.
All righty. Well, just wanted to point out if I ever have to deal with storm surge, then we're in big trouble. But for hurricane preparation, we got this question that asks, what's the one prep step with the best cost to benefit ratio? I was looking this up and kind of narrowing it down between a few things, and one that kept popping up was having a reliable backup power plan for essentials. And of course, this doesn't mean you need to go out and go get a whole house generator. There's other ways that you can do this, and I have a list of the suggestions there. And because the most common hurricane problems that we have are power loss related, not necessarily, wind driven issues or, of course we have flooding issues as well, but the number one thing is that you're likely going to lose power. And we witnessed that here in the upstate with Hurricane Helene, where lots of people were out of power for over a week, some folks even over 2 weeks, and thankfully it wasn't super hot afterwards. But the thing that you want to have is, there's a quality power station and battery backups that you can get to make sure that you can keep your phones charged and that you can keep, any kind of actual perishable foods from actually going bad, and also just keeping your overall batteries powered up for, flashlights and even like portable lanterns and headlamps as well. And so just having one of these whenever, you're expecting any kind of hurricane impacts in the area is definitely essential to have, because we're prone to losing power, and we certainly found that out during Helene when all of Greenville County and Spartanburg counties were almost at 100% outage. So just keeping that in mind.
Yeah, absolutely. And I would agree with that. That is the best way to go, because again, imagine, as you said, that it was cool, relatively cool after Helene, but down here in Columbia, we say we're famously hot. So you could even get a strong tropical storm, say in July or August, knocks out power for several days, and you've got that unbearable heat where suddenly you have no way to cool off. So definitely having something for your home, or at least on the smaller scale, just something to power something like a fan, your cell phone, staying in touch, things like that. And whatever it is, make sure it's part of your emergency kit and put it inside your safe room, wherever that is. And again, remember that your safe plan is going to depend on where you are and whether you're in a well-built home that's not in a flood zone, because obviously if you're in a flood zone or it's a manufactured home, a mobile home, then your plan might be to go to a sturdier structure, a friend or a relative. So definitely make sure all of that is in your hurricane kit. Did you guys, Charleston, Wilmington, any other tips on hurricane preparation real quick?
Something that I wanted to note, this is based on an experience from an old friend of mine. When you go to buy power inverters or chargers and things like that, pay attention to how that power is delivered to your device. Anything you have plugged in at home, like what we're using right now, all of our laptops and computers, that stuff that's plugged in the wall typically uses sine wave energy. I'm not going to go into all the nerdy details on that, but that's actually really important that your stuff is powered by sine waves. Because if you have another device or another charger or inverter that does not use sound waves, that potentially distributes an inappropriate amount of energy to your device and could potentially screw up your device and break it. Old friend of mine from undergrad fried his laptop because he had it plugged into a car charger that did not have sine wave energy in that inverter. So when you buy your stuff online, wherever you get it from, try to read the fine print on that to make sure that it is a sine wave inverter or charger or whatever you got. Just based on an experience from an old friend of mine, don't make the same mistake there.
Wow, that's a good point. I didn't even think of that. Wow, because you don't want to be in the middle of a power outage after a hurricane and now you have no laptop or whatever you're charging. So, wow, solid advice. Thanks, guys.
All right, Janet Radels, I'm assuming that's how you pronounce that. Apologies if I got it wrong. Asked a really great question there. What can people do differently if they truly understand the devastating power of a hurricane? Well, experience helps, right? If you've gone through one or a few tropical storms or hurricanes, things like that, you know what that does to you and you have a better idea of how to prepare. So experience helps. But on the other hand, you don't necessarily want to be too experienced, right? Regardless if you live on the coast or not, you don't want to run into any kind of bad situation and get caught with your pants down, so to speak. Let's be honest, hurricanes are nasty to deal with. This graphic here is a great example of that because these are multifaceted storms that give you a lot of concerns to deal with. Storm surge along the coast. Tornadoes, really no matter where you are, particularly in that right front quadrant that we discussed earlier. Damaging winds across the board. We've talked a lot about Hurricane Helene across parts of western North Carolina. and in the CSRA. I'm born and raised in Augusta. I remember that event quite well. Flooding across the entire area. Rip currents, what we see here a lot along the coast of our beaches. Multifaceted events that these are with hurricanes. So education comes first and foremost before anything else. Worry about educating yourself first with how exactly these storms impact you, and that way you're able to build a better emergency kit for you and your family. So really dive into the details here and understand what is a hurricane and what they're capable of. And then you look inward towards yourself and say, okay, I know what's happening with this storm, but what about me specifically? Where exactly do I live? What is my home made of? Do I live in a brick home? Do I live in a mobile home? Do I live in an apartment? And how does that structure impact on my preparedness and my risk, right? There's sort of a little equation here that goes into this. What event is happening and what I am exposed to. You have to think about those two things together in order to prepare, right? Take all of those things together and you have a better assessment of how you're able to prepare. Ready.gov is a really great resource to check out. Teaches you all about how to build an emergency kit, things to think about, like having a contact list, not just phone numbers of everybody, but having email addresses, physical addresses, right? You need to be able to go visit your friend's house 2 hours away, right? Because they have a better shelter available for you than what you have here at the coast, as an example. Having all of those ways to receive warnings. Phones are great, right? There's a lot of different apps out there you can download to get warnings and watches from us here at the National Weather Service. Well, what if your phone's dead? Or what if the cell towers are dead, right? Well, great. Your phone's just a useless paperweight at that point, right? Go out to the grocery stores, big box stores, really any of them have it. Go buy an actual weather radio. They range anywhere between $20 and $50 depending on the kinds of bells and whistles you want, but that is a physical tool that you add to your toolkit. So be educated about what exactly these storms are and what your risk is, and that just betters you to prepare in the long run, right? You have to have one first before you're really able to do the second thing in a more formal educational manner.
Great. Yeah, that was a great explanation, Ian. Thank you. So, and as I mentioned, this is the kind of the last part of our hurricane hazard series. So we've been going all month. So we started off with my presentation on the damaging wind and tornado component of hurricanes. And then we moved down to Samantha at the Charleston office. She told you about the storm surge and coastal impacts. We have Clay's presentation on inland flooding. So mind you, again, this is something that happens well away from the coast, as we've seen time and time again. And then we finally had Ian with his presentation on rip currents and distant hurricane impacts, because just because a hurricane's off the coast, it still can cause impacts. And then, of course, we heard from Melissa Griffin just going over hurricane history. So this kind of brings everything together. And with that in mind, each panelist has presented some closing thoughts. So I will go first. So as I mentioned here, we put this all together because hurricanes bring a variety of hazards, and they are just not that coastal threat. So if a hurricane or even a strong tropical storm threatens the Palmetto State in 2026, I want you to treat every tropical cyclone threat seriously, regardless of whether it's a Category 3, a Category 1, anywhere in between. Just keep that in mind, that all hurricanes bring some sort of threat, and just keep aware. Follow weather.gov. Follow each of the 4 offices. Make sure you're following us from wherever you live. We showed you the map earlier, so you know Columbia covers the Midlands, GSP, Greenville-Spartanburg, covers the upstate, and then the coast is divided by Charleston, and up towards Grand Strand you have our friends in Wilmington. So just keep that in mind and always be weather aware.
So my word of advice for the hurricane season is to rely on official forecasts from well-established sources like us, National Weather Service, National Hurricane Center, your local TV meteorologists, especially via social media, because there can be a lot of buzz out there on Twitter, Facebook, Instagram, now even TikTok. I've seen a couple of videos where people are, making their own forecast and saying it's going to make landfall for sure at this point when it's, 2 weeks out. So, rely on your official sources. That will tell you what's going on, and that will be the most truest form of what's happening. So be cautious of the sensational headlines that make you want to click on them. That's a very big thing now in today's world, so you just got to be cautious of like what's real and what's not real. And I see it all the time when I'm on social media as well, and I'll have to do a double check. So just be cautious of that. Follow who you know is credible, and you'll do just fine throughout the hurricane season.
Yeah, so my quote is, hope is not a hurricane plan, preparation is. The famous quote by Mike Tyson, everybody has a plan until you get punched in the mouth. And a lot of people found that out here in the upstate with Hurricane Helene, and of course the western North Carolina mountains. So basically what I want to reiterate is just taking all the information that you're getting through this preparation month as we head into the 2026 hurricane season, and actually taking this stuff seriously and being prepared before the storm. We have an emergency manager here in our area that likes to say, I don't hand out business cards, during a disaster. And so you can use that to reflect back to how you prepare for hurricane season, and that you need to do it beforehand. If you do it when the storm is right on our heels or it's actually happening, at that point it's too late. So just being prepared and taking all this information in that we're giving you is very vital for what's coming up ahead for this hurricane season.
All right. Preparedness pro tip, this is for me, this is personal experience. Stock up on battery-powered flashlights and lanterns. If you have any constrictions in your budget, maybe you just buy lanterns and just ignore the flashlight part. Here's my funny story behind it. At the very top of the presentation, Steve covered the hurricane names, and on that list you had Hurricane Isaias. That is a name that is repeated from the 2020 season. Remember, we repeat those names every 6 years, unless if they get retired. So Isaias is back in the conversation. In August of 2020, we had a hurricane make landfall in this region, Hurricane Isaias. That was my first official hurricane that I covered as a professional. I had not been here for a year yet. And it knocked out the power in my apartment complex. I was living in a one-bed, one-bath apartment at the time. Thankfully, it was only for 2 days, so I was okay. But I remember I worked 2 night shifts in association with that particular event. And one of those night shifts, I had to go back to bed and then immediately turn around and come back into the office the next morning. So I only got 4 hours of sleep or something like that. Everyone who works at the Weather Service knows about that whole life. I got up early that morning and I took a shower with the power out. I had a flashlight, but I'm trying to set up that flashlight on the countertop across the way and try to point it towards the shower. It doesn't really work out that well. And immediately I thought to myself, if I had a lantern, this wouldn't be a problem, because a lantern beams light in all directions instead of just one particular direction. So that was a lesson that I learned. I later bought a battery-powered lantern, so now I have the best of both worlds. So that's something that I personally learned. So buy both if you have the budget for it. If you can only buy one of those things, maybe just a lantern is the way to go. So that's a personal story that I learned, passing that on to you guys. We also have our hurricane guide there. We cover parts of North Carolina too, but really it's meant to cover everybody here. Anybody across the Carolinas and Georgia, really no matter where you live, there's always going to be something useful in our hurricane guide there. So I wanted to pass that along as well.
Yeah, and my final closing thought, something we still hear on social media or just from the public, but the cone of uncertainty is not a cone of impact. Hazards occur well outside the cone, so we still hear like, oh, I'm not in the cone, so I'm fine, or the cone's moving away from me. And don't focus on the cone. The cone is simply for where the center of the storm may go, and the winds and rain can be, a couple hundred miles, or it can be quite big. So you want to focus on the official forecast of how much rain, what wind, surf or wave impacts. Focus on the impacts from your trusted sources, the Hurricane Center, your local National Weather Service office. do not focus on whether or not you are in the cone itself. So we always want to hammer on that is, yeah, the cone is just for the forecast track, not for where the impacts are going to be felt.
Thank you guys on social media out there who responded to any of us. We got a total of 11 questions that we're able to share throughout all 4 offices. We had at least 1 participant, which was great. And so again, thank you so much for your questions. Remember to follow our offices on social media. So that's going to be NWS Columbia, NWS Charleston, South Carolina, NWS Greenville-Spartanburg, and NWS Wilmington, North Carolina.